And today's session is dealing with advanced emergency braking systems. And with me today, I've got Robert Smedley and Scott Simpson. Welcome, guys. Just a tiny bit of background. I'm the chair of the ATA, and we operate a family business in Tumby Bay. And it's pretty much a typical rural business. So we do a bit of livestock, refrigerated, flat top, taut liner, tipper, probably a bit of a sprinkling of everything. And before we sort of get started in this online event, I'll just mention that we run a fairly mixed fleet, and we've been speccing AEBS braking on our prime movers and trailers since December 2014, and since June 2019, we've specced all prime movers with the advanced emergency braking systems. So our belief is we really should be putting the safest truck we possibly can on the road. So, but anyway, with that, I'd like to welcome Robert Smedley. Just a tiny bit of background. Robert is the director of Smedley's Engineers, who gained prominence in the heavy vehicle industry as a key member of Norbrem's global team of advanced braking technology experts. So welcome, Rob, and I'll perhaps hand to you and I'll introduce Scott in a minute. Thanks, Rob.
Yep. So some of you may have come across me over the last 10, 15 years. I started with Norbrem's once I finished university after studying mechatronics and robotics, and worked with Norbrem's to introduce electronic stability control systems to the Australian trucking fleet. Worked with AEBS and ESC on truck manufacturers, Kenworth and Mack and Wabco. And then after finishing up with Norbrem's, I worked with Transport Main Roads for a bit, and then after that started my own engineering consultancy. So I'm here today with a background in electronic brake systems and to talk about the upcoming ADR 97, which is a new ADR that's been developed to mandate advanced emergency braking systems. So that's what I am here for this afternoon.
Thanks, Robert. And I'll go to Scott. Just a tiny bit of background again. In Scott's current position as Director of Product Strategy for Volvo Group Australia, he is responsible for ensuring the research and launch of new models onto the market, which involves working across diverse departments, both globally and locally, including engineering, after-sales, training, marketing, and finance. So over to you, Scott.
Yeah, thanks, David. I guess, as you mentioned, I've worked across a fair few different areas of the business here at Volvo Group Australia. So started out close to 25 years ago as apprentice diesel mechanic, and then worked through the retail and wholesale sides of the business. The last 7 or 8 have been in product management and working with our product development teams around the globe on introducing new products into the marketplace here. So yeah, that's it from me as a bit of a nutshell.
Yeah, thanks, Scott. And Tony, welcome to the podcast. Again, Tony is currently responsible for Wabco application engineering, truck, bus and trailer in Australia and New Zealand, and is called on to help in Asia as required. This role includes installation, testing, programming and release for production of advanced braking, suspension, control and safety systems such as AEBS. So a couple of quick words there, Tony.
Yeah, sure. Similar to Scott, I started my working life as a diesel mechanic. but following some rule changes in the New Zealand market in 1991, I started to specialise in pneumatic braking and also the fitment of ABS in those days, which was now quite a few years ago. So I've effectively worked with the Wabco product in one way or other since 1991. And as you say, I'm now responsible for the whole product range across the board, truck, bus, trailer, for this market and various others. So yeah, we do installation, testing and release for all products in this market.
Yeah, thanks, Tony. And probably what I omitted to mention was there's a lot of time being allocated for questions from anyone attending this podcast. So please feel free to put your questions in the chat room, and we'll endeavour to answer them. The other Scott, you've got a bit of a presentation, I believe. Do you want to play that quickly?
Sure, no worries. Just give me a second and I'll see if I can make it go live for everyone. Just let me know when you can see that okay, David?
Yep. Yeah, no, it's all good. Yep.
Okay. All right, look, I've probably prepared a bit too much information here, but I'll try and go through it with relative pace. So I guess to start with today, just a few areas I wanted to cover, and I'll go into different depths for each of these, but just a bit of a background to what ADR 97 is. So key points from what I presented last year and any of the changes that have occurred since then. Bit of a look at truck and trailer design systems in Australia. Bit of a question about, is it the chicken or the egg? Is it the truck or the trailer first? And then, what the base is from what we're talking about today that provides inputs for future vehicle platforms. So I guess to start with, and I've stolen this slide from Thomas from last year, but essentially key points here is obviously the fact of trying to reduce heavy vehicles incidents impacting the rear of other vehicles, and the cost there can be assimilated to about $200 million a year for the industry. Some study that was done by MUARC on AEB and what it means for Australia is obviously the opportunity to reduce the number of rear vehicle accidents. So when a vehicle runs into the back of another vehicle and causes injuries both to the driver of the vehicle that's being driven as well as the forward vehicle. And then what is the actual effectiveness of the system? So it's seen that the AEB can be up to 50%, 57% effective in mitigating or avoiding the subset of crashes. So it's not going to prevent crashes, but it's going to reduce the severity of the crash, essentially. And also, I guess, to summarise on the last point there, it's obviously looking to reduce the fatalities and the serious injuries with around 6.4%. So what is AEBS? Just as a bit of a refresher for people that are on the call. So AEBS is a system that alerts the driver at risk of collision with a vehicle ahead. It comes with a forward collision warning to start with by bringing up, depending on the specification of the truck, but generally an audible alarm, like a buzzer, goes off, and then also a flashing light, whether it be in the instrument cluster or in this case, like the right-hand image shows at the top there, it has a red line that appears on the dash as a heads-up display. And then if the risk of collision is imminent, and the driver has taken no action by either steering the vehicle away around the collision point or using the accelerator pedal to divert, then the actual vehicle brakes will be applied automatically. The part that we're going to discuss probably a bit more about this later today is the fact that it needs to be coupled to a trailer that has ABS or EBS systems for the trailer to be controlled correctly for some vehicle manufacturers. How does it look and see forward? The two lower images there, you'll see the left-hand one is showing the camera view. So in this particular case, the camera is mounted at the top of the windscreen. Some vehicle manufacturers, it'll be mounted at the bottom of the windscreen, but essentially the camera is the driver's eyes. It's another version of the driver's eyes. So it'll be mounted in the windscreen somewhere. And then the right-hand image at the bottom shows the radar. So radar's mounted in the lower area of the bumper bar, which looks forward to detect the vehicle ahead. So how does it actually work? If we look at this infographic from the very left-hand side, you can see the vehicle in the center there, traveling at 80 kilometers an hour, needs to decelerate to the car that is detected at the front that's traveling at 12 kilometers an hour. So to start with, from the left-hand side, once it detects the vehicle ahead and that there's no diversion or actions from the driver, it will actually bring up a pre-warning, which is the audible alarm and the solid bar or some sort of light in the dash in the first stage. And then in the second stage, you'll see the acoustics and the visual flashing. The third stage, which is probably the important one, is when we actually start to get a bit of pre-braking. So you'll see the green line at the bottom starts to show that we're getting some braking applied to both the vehicle and the trailers, depending on how the combination's set up. And then the very last stage is the final application of heavy braking to reduce the tractor-trailer combination down to 12 kilometres an hour to mitigate the collision with the vehicle ahead. So truck and trailer design systems in Australia. So I guess what I wanted to touch on here was we have different systems that are applied to trailers and trucks in Australia, which is obviously the subject of today's conversation. From my perspective, I see we have a strong heritage of trailer linkage to the US with the trailer type systems that have come out of the US over the last 30 years, whereas we have a higher or a larger population of European vehicles that are coupled to the front of those that has seemed to be growing in recent years. And to go with that, obviously we need to make sure that as the prime mover or the rigid vehicle at the front is the controlling device for AEBS, that all those systems work in harmony. So Europe are on board. We've had AEBS, ABS in Europe for sort of 20 years for ABS and EBS, and then when we moved to emergency braking, it's been in Europe for sort of the last 7 or 8 years. But when we look at North America, those systems are still lagging a little bit from what they provide today. And you can see by the right-hand side here, it sort of says that within 3 to 5 years, we'll see EBS coming to the US in a larger scale. So I guess as a technology taker in Australia, we've got many systems and levels of systems to try and integrate into our vehicle combinations. And I guess to lead on to that, when we look at the harmonisation between the truck and the trailers, we have ADR 3005, 3805 mandated last year for new heavy trailers to have ABS and roll stability delivered. But when is our local introduction for 97/00 for trucks? Could it be 2025 or is it 2027? That I don't know. I don't know what the larger conversation on that is. Originally, it was proposed to be 2022, but there's no news on that at the moment. So I guess the sooner we get that in, the better we're going to have with the harmonisation with our trailer configurations. And that will provide a realisation of the actual objective here is to reduce the heavy vehicle fatalities and serious injury crashes. So just some data that I pulled down from ASADA at the end of last week, just looking at where our trailer populations are and what it's doing. So we can see at the top here our total pool or total vehicle registrations. The actual pool there is growing year on year. So that's obviously to do with the freight demand that we have in Australia. We need more trucks, we need more trailers to deliver the goods. When we look at new vehicle registrations, obviously there's a fair bit of red there, and that's primarily due to the effect of COVID for this year. However, we're starting to see a bit of a return for prime movers, 1% up based on quarter 2 to quarter 3, the growth there. But when we look at retirements and the registration effects there, we have a large imbalance between rigids. So there's less retirements of rigids, but trailers, we see a large imbalance there where to me, it says that we're holding onto our trailers for longer, or the effects of COVID have said, hey, we need to hold that trailer for longer, or our freight demand is increasing. And lastly, with that, the median age of trailers is driving up from 9.8 to 13.6 years, which is outside how we see the median age for rigids and prime movers. You can see there it's relatively steady between rigids and prime movers at 14 or sort of 9 years, but the trailers are increasing massively. So where does all this technology lead to? And I guess just talking about autonomous solutions for us, braking for autonomous vehicles is one of the most important factors that we're going to have in the future. These ADRs are setting the foundation, as I see it, for autonomous vehicles in the future. So autonomous vehicles will need to be able to detect and brake accordingly, both not only for other vehicles, but for road users and the general public. So it's the platform for future technology. That's pretty much it that I wanted to share today, David. So I'll leave that for the question time, I guess, if there's any other questions, or I can take questions now.
Yeah. Well, look, what we might do, Robert, sorry, I didn't really ask, but have you got a couple of slides that you want to share, Robert, or a quick overview of your... You're on mute, Robert, sorry.
I'll fix that. Yeah, no, I don't have a presentation as such,
Right.
but I've got, I'll talk to a couple of points around the ADR 97 and where it's at the moment, more specifically than where Scott sort of led to. At the moment, it still is a draft sort of time frame for 2022 for this to be mandated in its current form. There's the federal government and the NHVR are both keen to see the AEBS mandate not sort of delayed in too much of a time frame. So in the last couple of weeks, the conversations that have been had with them were that they're keen to sort of still see it move forward in the next sort of 2-year time frame. So we probably won't see a 5 to 7 year delay. Well, they're keen for it to not take that long for it to be implemented, so that they can start seeing some of the benefit of advanced braking systems in the market and in the roads on reducing accidents. So that's probably the key things around ADR 97. It's mostly harmonised with the European ECE regulations. That's where the majority of our standard has come from, albeit a fairly rough cut and paste with a bunch of sort of drafting errors and stuff, as you can imagine. It is mostly a replication of the ECE standard, with a few minor exemptions on that. So that's sort of where ADR 97 has come from. So that's the act that will be mandating AEBS within the Australian market. Yeah.
Yeah, look, thanks, Rob. And Tony, back to you. Have you got anything you want to add to the conversation? And I'm just aware, I'll just mention again, look, feel free to send any questions in while we've got these experts on the line. Any questions are welcome. So, Tony, sorry, I didn't ask you before, but have you got anything? Yeah, have you got anything to share with this conversation? Sorry.
Sorry, I have nothing to present, but I think the time frame for 97, 7 years, I think, is a little extreme. I think 2 years is possibly a little optimistic. I'd be aiming somewhere in the middle there, maybe 3 to 4 years. There's a lot of work to be done for a lot of manufacturers, both on the truck side, but also on the trailer side. They're going to have to get up to speed to a degree as well. The biggest concern is, as Scott said, the number of older trailers we have out there. Rigid trucks, not such an issue, but as soon as you put a trailer into the equation, then there's a few things that we need to consider and as to how we're going to work with it and make it safe for everyone out there.
No,
It's
thanks,
an
Tony.
Sorry, David. I'm just.
No, you're right.
I think, it is going to be a challenge in terms of our ageing fleet. We have nearly, our average age of trailer is nearly twice that of what it is in Europe. So you can imagine if Europe has been had ABS mandated for the last 2 decades or so, pretty much all trailing equipment in Europe will have ABS by now. It'd be very rare for there to be something not to have ABS on the trailer. So our vehicle population in Australia is really different to what we have, what is in Europe as a result of that. Even America does not have the percentage of population with ABS trailing equipment that Europe does. So they're probably a little bit closer to us in terms of their fleet mix, but even their fleet is still more modern, or I wouldn't say more modern is probably not the right word, but less maintained but younger than our fleet. So they're probably closer to us than what Europe would be. So for Europe, mandating technology like this has been a rather simple task without having the risks associated with it that we have to also consider with the mix of fleets that we have in terms of age.
And look, I think, without run the risk of repeating everything said, even when I look at my own fleet, I mean, we certainly do hang on to trailers longer than prime movers. I think that'd be across the board, across the industry, that's how it works. So, in effect, you could probably be very general and say the trailer problem with this technology, it's a 20-year-old problem because it's not impossible to have a trailer for up to 20 years. So, yeah. We have got a couple of questions. Glenn Hambleton has asked, is AEB mandated in Europe? Perhaps, Scott, do you want to tackle that one?
Yeah. So look, it was mandated in Europe. I think it was in 2013, but it's definitely mandated in Europe.
Yeah. I think you guys can see the questions as well. Adam Gibson's asked, well, I could read the whole question. A question for Rob or Scott: what would happen next if a prime mover equipped with an AEBS that does not downgrade its function in the absence of a detected smart trailer was to make an emergency 100% brake request of the trailers in a B-double combination in heavy traffic? What happens next is likely result in good outcomes for the public or the transport industry. And I guess that's reverting back to the trailer question, isn't it? That's the same.
It's the crux of the issue with this mandate, really. Yeah. Do you want to go, Scott, first, I suppose?
Yeah, look, I hope I've understood Adam's question correctly, but essentially the prime mover or the rigid vehicle that's the lead in a towing situation needs to have an EBS or ABS lead coupled to the trailer for it to then supply emergency braking control, essentially. If it's on EBS or ABS, if it's a dumb trailer that's coupled to a smart truck, then depending on the manufacturer, it can supply a reduced pressure signal to the service line to slow or to assist with the slowing of the combination and try and maintain stability, try and maintain trailer, keep the trailer in the lane, essentially. So I hope I've answered that correctly to your question, Adam.
Yeah,
Perhaps, Scott, if I... Yeah, well, I'll just twist that a little bit. Am I right in you're implying, Scott, that various manufacturers have different scenarios in the instance where you've got a AEBS prime mover and, say, a dumb braked trailer.
Correct.
Yeah.
So if the truck has obviously if the truck's coupled to an EBS trailer and the EBS lead is connected, then it will apply either moderate or severe braking pressure to slow the combination down in the event of emergency braking situation. If the truck is coupled to a non-smart trailer that doesn't have ABS or EBS, it's just got obviously your lighting plug and then your service and your emergency airlines, then the truck will, if it detects that it needs to slow super quickly for an emergency braking situation, then it will only supply a modulated reduced air pressure to the signal line on the trailer to help it slow down. So it's not going to be at the same rate of control as it would if the truck and trailer combo was complete EBS.
Yeah, sorry, Robert.
Yeah, no, that's fine. I jumped in and wait my turn, David. I should put my hand up. So a bit more to that. So some of the manufacturers, truck and trailer manufacturers truck manufacturers are dealing with the issue of a non-ABS trailer differently. And I think this the ECE doesn't actually specifically state how a truck or trailer should handle a non-ABS trailer. So different OEMs have sort of decided on their own sort of moral compass, I suppose, so to speak, as to what they think is the right way to handle it. And I think this comes from a background in, like, obviously I've got a background in robotics. I studied robotics, and one of the fundamental philosophies of robotics is that a robot must do no harm to a human. So artificial intelligence, we hear about this all the time. And the idea that a robot or a man-made machine of a robot that thinks for itself or acts for itself should do no harm to any human. So that's a fundamental philosophy of robotics that's been around since sort of early days of automation. And some of the manufacturers, or a step in between that, a lot of people would now be starting to see that we're looking at more and more autonomous vehicles. So autonomous cars that drive for themselves, hands off the steering wheel, and no interaction, so to speak, with a driver. So the vehicle's able to make its own decisions and decide what it's going to do and how it's going to interact with traffic. And in the last couple of years, we've seen more and more discussion and debate about how vehicles are to make those decisions. And one of the fundamental requirements of an autonomous vehicle now is that it must not cause an accident. That's an autonomous vehicle. So and that is pretty much all but written into law now for autonomous vehicles, that they must not cause an accident. So one of the steps that seems to have now come from that is that OEMs are also now looking at where this technology is heading. It's not just going to stop at AEBS, it's going to keep going. And we'd be sort of somewhat ignorant to think that AEBS is the end of the chain here. And so a lot of manufacturers are looking ahead to where this legislation's now heading and what the legal ramifications are around the decision-making process of this technology. And they've turned around and said, well, we need to make sure that our AEBS systems do not cause accidents, okay? And that's where we sort of start to see the difference in decisions that some manufacturers are going to start looking at. So some manufacturers will say, well, best thing to do is to apply the brakes anyway, regardless of it's got ABS or not, so that we can reduce the speed of the combination. And other manufacturers are looking at that and going, well, if we want to head down the path of not causing any accidents, we want to make sure that it's actually not going to create a jackknifing event or a trailer swing event where those trailers would swing out of lane and collect with another car that they otherwise wouldn't have had the brake's not been applied. So we're now getting into a different philosophy, I suppose, so to speak, as to how OEMs are starting to handle this decision of, is my goal to reduce the speed of the vehicle to stop hitting the vehicle in front that I otherwise would have? Or do I go down the path of I must not cause any accident and therefore create an instability in a combination that wouldn't have otherwise happened? So we're sort of starting to, and this is where now we're starting to verge on this moral decision-making process of, is the vehicle causing an accident or is the vehicle preventing an accident?
Yeah, can I just make a comment there too, that one of the biggest issues that we have here, or one of the bigger issues we have here, is with multiple trailers. Regardless of the prime mover on the front, if it has a trailer detection circuit that can determine, yes, I've got a trailer behind me, and that trailer has EBS or ABS, whichever. We then put a dumb trailer behind that. How does it determine that? So it gets very, very difficult to try and get a fully compliant, if you like, fleet in that way. But one of the other things, I don't know if many are aware of, but certainly our system, if AEBS goes into a full emergency brake function 3 times in the life of that system, it goes into fault mode, stops working and puts a fault on the dash. That is how often the manufacturers of those systems believe they should work, because they are only an addition to a driver. If the driver is paying attention, the system will never work. If the driver is paying attention and he sees an incident in front of him, he is not going to sit there and think for a minute, wait, what trailers am I towing? Do I have to modulate the brake pedal, or do I just stand on it because I think I'm going to die? So there's a lot of areas in this discussion that need to be considered. All of these systems are no replacement or no alternative for a well-trained, attentive driver.
No, and that's a very good point, Tony, actually. And yeah, I mean, in a sense, these are sort of backup systems, really, in the event that, either from lack of concentration or whatever. But Ian Thompson's sent in a question, what voltage is ABD in is it on 12 or 24 or multi, and how do they cope with multi-combination B-double? And I'll perhaps go to you, Tony, because you touched on multi-combination, but it is Australia. We have single B-double, Type 1 road trains, Type 2 road trains, from BAB quads to AB triples to you name it. And it's a good question.
No, the answer is it's the truck system. So it's whatever voltage the truck is. And what the AEBS system does is if it determines it needs to apply the brakes, it actually asks the brake system to do that for it. So the brake system then uses the conventional method of either electronic control lines, if it's an EBS truck, or the blue line to the trailer. So voltage of the AEBS itself on the truck is completely irrelevant as far as the trailer control goes.
So then another question then, how, if your prime mover is 12 volt, how do you cope with, i.e. 4 trailers over 53.5 metres, a Type 2 road train, for example?
You don't.
That's
right. You've never been able to cope with that with 12 volts at the front.
Yeah. Ian Thompson's also put in, does the driver get a signal at the start-up to indicate if the AEBS is going to be active or not? I think probably the answer is yes. May be relevant to the manufacturer a little bit, but normally you would get it. Yeah. So I think most manufacturers would.
You do, yeah. You get a light to confirm that it's connected and working, or you get a message and a light to say that it's not, essentially.
Yeah. And it's also an ADR requirement, NDCE requirement, that whenever the vehicle is turned on or off or restarted, that it must go back to the default state, which is to be active. So some of the manufacturers have override switches where if you're in an off-road scenario, like carting logs out of the bush or something like that, you'd probably want to turn it off. And when the ignition is cycled, then the AEBS must restart again. Yeah.
So the question, I suppose, in my mind is, how do we get some kind of uniformity amongst manufacturers and for the end user, of course, in these systems? And I certainly don't have the answer. We, like I said at the start, we run a mixed fleet and combination of EBS trailers and dump trailers. But I think therein lies part of our current problem, I'd suggest. Does anyone want to put their hand up with that one?
Pass.
Pass.
Well, so it's an interesting point. Adam Gibson also asked about this, or made a suggestion, I suppose, about this. And I'd been contemplating this as well. I think at the moment, in the government, both federally and state, we're seeing a lot of money get handed out for new equipment to be purchased, for subsidising, all sorts of things to make the economy sort of kick on. And hopefully safer as well at the same time. And so one thing that I think the government could seriously consider and would be a lot less impact financially for the government, but also producing safer vehicles on the road, would be to heavily subsidise the retrofitment of EBS onto trailers. So if the government, if both federally or state, threw in money into the tin to pay for the retrofitting of trailers, or 50% of the retrofitting of trailers with EBS, we'd resolve a lot of this problem of the ageing non-ABS fleet, and we'd also have some serious safety benefits rolled out within our transport sector, and we'd be creating a fair bit of work for a lot of people in the retrofit program as well. So I think in my mind, I think it's probably a win-win for most of Australia and most people of Australia in some level, if the government seriously took on a subsidisation scheme of retrofitting technology like trailer EBS into the fleet, the national fleet. And that's something that I've sort of been contemplating for a bit recently.
Well, the outcome would certainly, I mean, arguably we'd have a lot safer fleet in Australia if we could get to that, Rob, but there's a few hurdles in that as well. Scott Clayton has sent in, do you think there's a danger of drivers becoming too relaxed with their attentiveness to the driving task when they believe their AEBS or ABS will kick in to stop the truck in time? Unfortunately, we have seen this exact scenario where a driver waited for the AEBS to engage, and during the whole event kept eating his sandwich. And if I just twist Scott's question slightly, there's plenty of reports out there of drivers relying on EBS trailers and stability control too. So it goes in that same theme. I think that, and that probably you're reflecting a little bit on completely autonomous vehicles, perhaps. But does someone want to comment on that question from Scott Clayton?
Yeah, maybe if I can start there, David, is to me that particular situation and scenario sounds about it more like education. We've seen the similar sort of things like you mentioned with stability control, where drivers will just get in the truck and not know its capabilities with that type of system, and they test it to the limit. So essentially, I think part of that problem is probably education of the system and how it operates.
Yeah. Is there anyone else? Tony, have you got a comment on that one?
Look, I think there is a risk of drivers becoming a little reliant on these systems, if you like. We all know that there are drivers out there who are already doing that. But by the same token, fleets also say it is becoming very, very difficult to get experienced drivers. So do we not need to then provide the inexperienced guy with the safest possible suite of systems? It's a two-edged sword, I guess. The more
Yeah.
self-reliant you make the vehicle itself, you maybe dumb down the driver. It's a difficult one.
Well, very good comment, actually. Yeah. Have you got a comment on that one, Robert?
Yeah, it is something that's been, well, even going back to when cruise control started becoming common fitment in trucks, there was things around whether drivers would become lazy due to having cruise control and moving from manuals to automatics. Definitely, when automatics started becoming more and more popular, the question was: is the driver just going to get more and more lazy and less attentive to what they're actually doing? And I think the problem we have is we've got a driver shortage as it is, and over and above a driver shortage, we've got a quality driver shortage over and above that. So I don't know that dumbing down our safety technology is going to be the answer to it when we've got serious problems trying to get enough drivers in bums on seats, I suppose, so to speak, as it is. So, yeah.
Actually, I'll go back to a question from, it's probably a comment really from Glenn Hamilton. Hopefully by the time this system is mandated, all trucks built will have standard 24 volt voltage. All trailers more than, well, where you have three in a combination must be 24 volt powered. I'm not sure but is he's got that written in ADR 38, but does that actually apply to i.e. AEBS braking in trailers at this stage?
I think the new 35 regulation is going to require if you have a prime mover capable of towing road trains, you must have 24 volt power to the trailer EBS systems.
Yep.
So,
Yeah.
But as we know, because of the turnover of the fleet, even let's say that mandate comes in the next 12 months, it's a good 6-7 years before half the fleet will be at the point where it has that. So you're really looking at 10, 12 years before you start seeing the real effect of ADR changes in the actual overall fleet.
Yeah. Bob Martin has made a comment that Honourable Minister Scott Buckholtz confirmed retrofitting of safety equipment to trucks and trailers will qualify for the instant asset write-off scheme. So there may be a glimmer of hope in well, that's not quite your suggestion of perhaps the government funding 50%, Robert, but it's a step in the right direction at least.
Yeah.
Ian Thompson has asked what is done for in-service checks that the systems are still working. In other words, diagnosis checks. Has anyone got a comment there?
Yep, sure. I'll start on that one if you like. The systems are self-diagnosing. Generally, when you first power them up, as you move away, they do a self-calibration check. They check wheel speeds, etc., lateral accelerations against various other systems within the vehicles. So they will effectively analyze themselves constantly as the vehicle is being driven. If something comes up or they detect a anomaly which they can't self-calibrate for, then they will alert the driver that the system has gone into a limp mode or a non-active mode. But they are effectively maintenance-free apart from making sure that you don't hit them with the water blaster too hard, and they will look after themselves.
Yeah, and that's true, Tony. I mean, I made an inquiry the other day from a manufacturer about getting software from a laptop to download an trailer EBS systems, and reality is there's no need. You can, on the little screen on the trailer, you can get most of the information you need from there anyway. So there is actually really no need to buy additional software or anything for these systems. Yeah. Look,
with software you can normally dig deeper, but you can certainly get all the information you need normally off the dashboard, or as you say, the trailer display.
Yeah. Scott Clayton has I'll read it. Thanks. Education is certainly the key. Nevertheless, it is a conundrum, and there has to be a balance between driver attentiveness and reliance on the safety technologies. And Scott's exactly right there in terms of education. But the first thing that comes to mind is all the different scenarios when you talk multi-combination, and some trailers with EBS and some without, and to provide that training for drivers, etc., is probably fairly difficult as well.
Yeah. Probably if I can just make a comment.
Sorry, you guys.
Sorry. Yeah, look, I was just going to say, I think with your opening statement there, David, and the fact that the ADR has been written in such a way that it talks about advanced emergency braking, not autonomous emergency braking, because even when I read that last year, I sort of thought, well, we're a bit ahead of ourselves there. And essentially, it is that these are not autonomous vehicles. We're still another 10 years away from that, but it's helping the driver as a support system. So it carries back to be, giving them an advanced feature set for when they're driving. So essentially, in an emergency braking situation, they're still the primary source of trying to mitigate that situation. It's just a support system to help them along the way.
Sorry, Robert.
No, all good. And Adam actually mentioned a question there about, false. He was talking more about insurance issues and when a jackknife was to occur, but he touches on false positive triggers of full emergency braking systems. And one thing that I think it's worth pointing out about AEBS systems is the ECE and the ADR subsequently are written such that the manufacturers have to ensure that false triggers are minimized, i.e. they have to err on the side, they have to be very confident that there is actually going to be an imminent accident before they apply brakes. So it's not a matter of, we think there might be an accident, so we'll apply brakes. The manufacturers of the systems have to be quite certain that there is an imminent accident going to occur before applying brakes. Now, one of the ways that the manufacturers do that, the earlier systems of AEBS had only used radar systems. So they only looked at what objects were in the field of view quite broadly. Scott actually had a good image there where he showed the radar and the camera. So what the radar actually can just tell you distance. It can't tell you where an object is. It actually can't tell you if it's in your lane or out of your lane or where it is. It can only tell you forward distance. Whereas a camera, when the systems are now correlated more recently to camera data actually can tell you orientation of objects as well. So it can tell you, is an object in the side lane or off the road altogether, and it can actually orientate where the vehicle's going, where the vehicle's heading, and what objects are in that path. And it correlates that camera data to the radar data to have more confidence about what objects are actually likely to be in the collision path. And as a result, not everyone's using camera data. I'll point that out at the moment. But the systems that are using camera data and are correlating the camera data will provide much better outcomes than the systems that are simply using radar at the moment. So the standard only requires radar. So it's it's quite reasonable or quite possible that manufacturers will only supply radar solutions. But there are systems now that are correlating more and more sensor data to get a better picture of what the vehicle is doing on the road, and therefore minimising false interventions of AEBS. In the event that the second point of what Adam's sort of talking about, in the event that a further accident was to occur, like a jackknife or something was to occur in the event of an AEBS intervention, I think we'd have to wait and see what happens in a court case on that one, because I don't really think, I wouldn't really know how that would handle out. There's so many variables that I think it'd have to go before a judge to determine who was at fault and who was at risk in an accident scenario like that at this stage.
Yeah, I was involved in a court case, not exactly to do with AEBS, but with a incident where we had a smart truck and a dumb trailer, and the upshot of it was that the trailer ended up being braked to the point where it locked its wheels, and that swung into the oncoming lane. Driver was found guilty in that case for inattentive, because if he had been driving more appropriately to the conditions, regardless of whether he hit the brakes or an autonomous or an automatic system hit the brakes, the outcome would have been the same. But one thing I think I should mention with regard to false alerts or false positives is that the development period or requirement for a lot of these systems is 250,000 kilometres of accumulated mileage per vehicle, per model. So it's not just, hey, we've made this bolter on the front, you're off. We test these things on each individual vehicle model. We send the radar and the front bumper assembly or the front cowling assembly to a test chamber, and that gets analysed and approved for, okay, the actual front of the vehicle itself is going to cause no harm. We then send these things out on the road for 250,000 kilometres in what we call monitoring mode. So it is watching, it is recording, and we can analyse all that data. It does not work in that 250,000 kilometres. And that is purely to make sure that we have good, accurate information that it is not going to cause a false activation. So, it's a very complex system that is not released lightly into the market.
And just to extend that, Tony, John Allen sent in, it's important radars and cameras are not obscured by bull bars, stone guards, etc. I mean, it's probably a bit of an obvious statement, but with your testing, is that carried out with like various bull bars designs and things like that, in the sense that we are in Australia and most trucks have a bull bar of some description. So is that the case?
Yeah, bull bars, any change to the front of the vehicle needs to be retested effectively by the manufacturer to make sure that there is no impact on the system.
Yeah, and probably just to add to that too, I mean, we've seen cases where radars are being remounted off-centre, and then the truck has a series of faults because it's picking up on vehicles in the other lane. So essentially, I can only talk for my group, but yeah, we have instructions that are available for bodybuilders as to where and how they need to manufacture bull bars that are clear of the radar at the lower half of the vehicle.
So, yeah, it appears to me that, I mean, really we're talking about safety both for drivers and the motoring public, the other people on the road. And while this is a quest and a move in the right direction, it appears to me we've still got a long way to go to perhaps get any sort of uniformity, particularly with multi-combination and various trailers. Would it be appropriate to consider amending or add a performance-based requirement to the application of the service brake control for, i.e. non-ABS equipped trailers? Is that something that may be worth considering moving forward?
Yep. Do you want to go first, Rob? Or?
No, I'm going to go last on this one.
Okay.
Well, I'm only just putting it out there.
I think it's quite clear in Australia that we're going to have a lot of older trailers in the industry for a longer period of time. So essentially, to me, I mean, there needs to be some criteria around there as to how these systems interact with non-ABS and EBS type trailers.
Yeah. So did you have anything there, Tony, or?
No, look, I think we've got to come up with some method of dealing with the vehicles that are out there, the older vehicles that are out there. As Rob said earlier, if we could retrofit EBS or ABS to every trailer, outstanding, job done. Yeah. But it's unlikely for that to happen. So yeah, we have to come up with a united approach as to how it is dealt with.
Yeah. You said you want to go.
Yeah, I think that's really the crux of it. Is there's probably a multiple ways that we could solve the problem, and one would be updating the fleet, and that would be fantastic. But in coming back down to ground and reality, the concern is that my concern is, and I touched on it before about autonomous vehicles and technology not causing harm, so not causing accidents. And I personally would lean more towards ensuring that any ADR that we introduce does not cause accidents or does not result in scenarios that can cause accidents. So my personal preference would be to develop a standard or to actually have the ADR as a requirement where gross wheel lockup of trailers is not allowed under an AEBS intervention, i.e. Therefore it doesn't matter how manufacturers determine to do that. It could be through fitting ABS to trailers, or it could be through changing modulating control signals or whatever they want to do, or it could just be don't apply the brakes at all, only do engine braking, for example. But a simple line like that, no gross wheel lockup of the trailers, would solve the performance outcome and prevent any causation of accidents. So that's my personal opinion. I'm not a vested interest either way, but I think we should be. It's going to come anyway. We're heading to the world of automation, and I think that's ultimately going to be where it lands. Noting the fact that recent research has suggested that even when we have 100% automated vehicles, autonomous vehicles on the road, they expect that we're only going to reduce accidents by about a third. It's not going to entirely be the end of road vehicle accidents, even then when we've got full autonomous vehicles on the road. I think we should be heading down the path of reducing causation, not just looking for a middle ground, so to speak.
Yeah, we're actually running out of time. I'll just mention Richard Calver and Sharon Middleton. I'll combine those two, where there is still confusion about the activation for pedestrians and Australian wildlife. Can you please provide an update / state of play? And Sharon, made a comment, radars need protection from wildlife, roos, emus, camels and eagles. And I mean, there is an underlying problem there. Does anyone want to touch on that one quickly?
I can quickly do it. The ADR states that, and the ECE, that the vehicle that it's looking for, the object that is looking for, is for a sedan. So anything smaller than a sedan, the system won't activate. It's not until